Today we're looking at arc length and radians. Your essential question is, how do I find arc length and how do I convert between degrees and radians? Learning intention, I'm learning to find arc length and to convert between degree measure and radian measure. You have two warm-up questions. Find the indicated variable and find the arc length. So, pause the video and see if you can do that now. Well, I hope you tried. When the vertex is inside the circle, we add and divide by 2. So 155 plus 79 divided by 2 will give me my degree measure. And I end up with 117 degrees. And we're done. The next one is a little bit more involved because we know this piece, we don't know this piece, but we can find this intercepted arc. If it is on the circle, if the vertex is on the circle, you divide by 2. So if we need to know that length of that arc that it intercepts, we multiply by 2. 95 times 2. And that will give me 190 degrees. But wait, we did not find the right arc yet. What other information do we know that we will use? Well, the whole circle is 360 degrees. So I will take 360 degrees minus 75 degrees plus 190 degrees. Using my handy dandy calculator, 360 minus parenthesis 75 plus 190, close it off, and I get 95 degrees. Guess what? They were the same. One was 75 and one was 95. Need to erase this so I can put that other parentheses that I left off for whatever reason. Okay, take a minute. If you're still kind of shaky on this concept, take a minute and look at it. We've got 2 more to go. Remember, if your vertex is inside the circle, you add them together and divide by 2. If it is on the circle, you divide by 2. If it is outside the circle, you subtract and divide by 2. If I am looking at this, I want you to stop and think, what do you know about this figure here? How many degrees will be in this figure? If you said 360, you would be right. So if I have this one be x degrees, then I'm looking at the whole thing would be 360. 360 degrees minus x degrees will give me this piece here. Then I still have to subtract x degrees again, and I will divide it by 2, and I will get 50 degrees. We know this piece is where that 360 minus x is. So first thing I'm going to do is simplify. 360 minus 2x over 2 is equal to 50 degrees. At this point, I've got several different things that I can do to simplify. 360 and 2x are both even. I could divide 2 out of both of them. Or I can multiply both sides by 2 and work with a little bit bigger numbers. Okay, we'll divide by 2. 360 divided by 2 is 180 degrees. Is minus 2x. Is equal to 50 degrees. I am going to subtract 180 from both sides. Negative 2x is equal to 130 degrees, and that's going to be negative because 180 is greater than 50. Divide both sides by 2, by negative 2, and x is equal to half of 130 is 65. If that's 65, 360 minus 65 would be 295 degrees. We found all the missing pieces. So if we're looking at the next one, instead of asking for the intercepted arc, they're asking for everything else. If it is on the circle, we know that we simply divide by half. So this is going to be 76 degrees times 2. And you end up with 152. But I need to find this piece over here. Well, the whole thing is 360. Now I will take 360 degrees minus 152 degrees. If it was 150, it would be cut in half. 152 means it will be 148 degrees. So your question mark is equal to 148 degrees. We always have to have vocabulary. So something is the distance along an arc measured in linear units. If I look down below, it kind of gives me a hint what goes in. Arc length goes in. So, if you think about it rationally, I've got these arcs up here. Your arc length is going to, the circumference of a circle is 2 pi r. If we take that part of a circle we're looking at, divide it by the whole circle, we'll see the fraction of the circle we want. So to find your arc length, you take x, where x is the degree of the central angle, divide it by 360 degrees, and multiply by 2 pi r. So if we're going to apply this, I know that x is equal to 80 degrees. My radius is equal to 3 foot. Substituting it in, arc length is actually s. My x is 80. 80 degrees over 360 degrees times 2 times pi times 3. Any questions? Okay, so what's the next step? If you look, we've got 2 times 3 up here. So my arc length will be equal to 80 degrees over 360 degrees times 6 pi. Guess what? 6 goes evenly into 360. 6 divided by 6 is 1. 360 divided by 6 is 60. We can actually factor out a 10. This becomes 8 over 6 pi. Can we leave 8 over 6? No, we have to simplify. They're even. I can divide out 2. So this becomes 4 over 3 pi feet. If you're looking at it, it is in feet. Take a minute. Back it up if you're not understanding the process. You have to know the degree of your central angle. You have to know the radius, and then you can apply the formula. Okay, for the next one, remember this is x over 360 degrees times 2 pi r. 2 pi r is your circumference. So if I'm looking at it, x is how many degrees? 120 degrees. R is how much? 11 centimeters. Putting it all together, 120 degrees over 360 degrees is times 2 times pi times 11. Okay, I can divide it in half. 1/2 of 360 will give me 180. So now I've got 120 degrees over 180 degrees is equal to, or times, pi times 11. Still not done. I can simplify. I can divide by 10, get rid of my zeros. 12 over 18, both of them have a factor of 6. 12 divided by 6 is 2. 18 divided by 6 is 3. And then times, I'm going to move these around. You can because it is commutative, 11 pi. 2 times 11 is 22 over 3 pi, and this will be meters. 2 times 11 is 22. You still are over 3. 22 pi because you've got pi in the denominator. And this arc length would be 22 over 3 pi feet. We leave the pi in because that gives us that exact that we always need. Okay, you've got 2 on your own. Pause the video and see if you can find the arc length on your own. What is the arc length of RS and what is the arc length of FE? Okay, identify R and identify X. X is 65 degrees. R is 7 feet. So, putting it all together, 65 over 360 times 2 times pi times 7. So if we're looking at this, we know that we can factor out a 2. This becomes 1, this becomes 180. I can factor out a 5. So 180 divided by 65 divided by 5 gives me 13. And 180 divided by 5 gives me 36. Can I do any more? Does 13 go evenly into 36? No, it does not. So now I need to take 13 times 7. And I end up with 91. So I've got 91 pi divided by 36, and this will be feet. Okay, if you didn't try that one on your own, pause the video and do the next one on your own. Find your X, find your R, and apply that formula. X degrees is 20 degrees. R is 9 centimeters. 20 degrees over 360 degrees times 2 times pi times 9. That looks like 368, but it's supposed to be 360 degrees. Okay, if I'm looking, I know I can divide 9 out. So 9 divided by 9 is 1. 360 divided by 9 is 40. I've got 2, I've got 20, I've got 40. I can divide out that 10. This is so 2 times 2 is 4. 4 divided by 4 is 1. So this simply becomes pi. Now, if I am not sure, I can always put everything in my calculator using my parentheses. So this will be 20 times 2 times 9, close it off, divided by 360. I'm going to hit my math button. I'm going to hit enter and enter again, and I end up with 1. So it's simply pi, and that will be centimeters. When we're using the calculator, we always tell you to make sure you are in degree mode. Degrees and radians are two different ways of measuring. So if you want to know what radians are, 2 pi radians is equal to 360 degrees. So if you go all the way around a circle, you've got 2 pi radians. So if you want to think about what happens when I divide it by 2, you end up with pi radians is equal to 180. Divide both sides by 180, and you end up with pi radians over 180. So to convert, if you've got degrees, you multiply by pi radians over 180. And we'll look at the why of it. So this will be 130 degrees times pi over 180 degrees. I'm going to leave off the radians for now. My degrees will cancel out. I can divide top and bottom by 10. I now have 13 over 18, and this becomes 13 over 18, 13 pi over 18 radians. What about 45 degrees? Think about it logically. 45 degrees is 1/2 of 90. There are 4 90 degrees angles in 360. So this would be 1/8 of a circle. So if we put it into and multiply by what we're going to multiply, 45 degrees times pi, divide it by 180 degrees. Once again, it's quick and easy. So this would be, actually there would be 4 45s into 180. So if I put 45 divided by 180, hit my math button, hit enter, enter, I get 1/4. Like I said, it is 1/4 of a circle. So this is equal to pi divided by 4 radians. Pi divided by 4 radians. Okay, pause the video. You can do the last one on your own. If you do not want to simplify the fractions, put them in the calculator, hit your math button twice, and it will simplify it for you. Pause the video and find how many radians 260 degrees is. Okay, so that's 260 degrees times pi over 180 degrees. 260 degrees divided by 180 degrees. Math button, enter, enter, and I get 13 over 9. So this becomes 13 pi over 9 radians. Okay, so now if we're going to convert radians to degrees, we're going to multiply the radians by, guess what happens here? It is flipped over. It's going to be 180 degrees over pi. Up here, our degrees canceled out. When we get ready to multiply by 180 divided by pi, our pi's will cancel out. Pi over 6 times 180 degrees over pi. Pi divided by pi cancels out. 180 divided by 6 is 30. So this is equal to 30 degrees. Once again, 3 pi over 2 times 180 degrees over pi The pi's will cancel out. 2 goes into 180 degrees 90 times. So 3 times 90 gives me 270. This would be 270 degrees. Pause the video and do the last one on your own. I do hope you tried. 7 pi over 8 times 180 degrees over pi. Your pi's cancel out. Okay, I'm going to use my calculator. Parentheses, 7 times 180, parentheses, divide by 8. Math button, enter, enter. I've got 315 divided by 2. If I wanted to do the decimal, I'd go down to the decimal. 157 1/2. That would be degrees. So hopefully you'll be able to figure out how to convert and how to find the area of sectors, or find the arc length of your sectors. Convert degrees into radians. Radians into degrees. That gives us that double-sided arrow. We're going both ways. I hope that you can get it figured out. If not, we'll need to talk.